I'm showing you guys how to do a reball on a PlayStation. It's a little bit more delicate than working on an Xbox for the reason that you have a lot of extra components surrounding the BGA chip. So it's something you need to be more delicate with, but I'm going to go ahead and give you a run through the process. This is a fat model PlayStation. I've already stripped it down. As you saw in my other video, I removed the IHS to make it easier to lift, and I've also put a layer of flux around the chip. This is just a basic paste flux to help transfer the heat so we can get a good clean lift. Also, this is a tent. I make these tents out of aluminum tape, several layers, and then I cover them with Kapton tape. Kapton, K-A-P-T-O-N tape, you can find on eBay. Best bet is to order it from China. What that is a heat reflective tape. It'll actually reflect the infrared off of this heating unit. And also, it's a good place to put your chips when you pull them off. I actually put a little layer on my table. Wood doesn't conduct heat very well, so that's why I put a layer, because the wood will keep it from cooling too fast, and the layer of Kapton keeps it from sticking to the wood when I place the chip on there for cooling before working on the reball. And that way it's easy to lift up, obviously. So we'll come back in a minute. One of the cool things about PlayStation chips is they have a lot higher heat tolerances. The one thing though is the pads on the bottom of the chip and on the board are very delicate. So if you don't have a really good preheater, and I'm going to make a video going on about preheaters and hot air systems and all the different systems you can get. If you don't have a good preheater that can heat up this board effectively, you are not, and I repeat, you are not going to be able to lift this chip without destroying the board, damage it beyond repair. So even with best practices, it's possible. Okay guys, so we're getting up to the melting point here. Also, I'll be posting my profiles that I use for my Achi machine, temperatures that need to be hit later on. I'm going to hand the camera off to my helper and show you how we lift the chip up off. So we're getting up towards the melting point. What I want to do is, you should be doing this if you're doing a reflow or anything, is you want to nudge the chip just a little bit. And we're seeing that the chip is moving. So that way we know all the solder balls are melted and it's ready to be lifted up. So we're going to swing the top heater out of the way, and we're going to quickly lift this chip up and off. So there's our graphics chip. We're going to set it down on that heat surface that I talked about earlier in the video. Now, as we can see, I'm going to go ahead and hit my cooling switch here. Move the temperature sensor, and we're going to move this out of the way. So there's your perfect lift right there from the ball grid array. And I'll be back in a second. I'm going to show you how to remove the solder. Okay. Alright, so a couple of things I'm going to be using here. This is my RU968. I have a blade tip on my soldering iron. That also has a fume extractor, which is very nice. This will be going over later. This is my tip cleaner. I prefer the steel kind as opposed to the sponge because it doesn't ruin my tip. This is Kingbo Flux. This is uber cheap paste flux, and I just use this for cleanup. It's water soluble, so a little bit of isopropyl alcohol and you can clean up the pads very nicely. Goot Wick, you want to get the genuine kind. This is actually a rip-off kind. You can tell by this little lip it has on it. They sent me this by mistake, or I mistakenly ordered it from a scammer, whatever you want to call it. And this is what we're going to use to clean up the extra solder left on the pad. So again, hand off to my buddy. Now this solder is beginning to cool. So the first step in this process is I'm going to clean my tip, and I'm going to wet the tip with a little bit of leaded solder, which is going to make it easier to pick everything up. So now I'm going to take my Kingbo Flux and I'm going to wet this place. This board is still in the process of cooling down, and we want it to be. We don't want it to be at 225 degrees, but we want it hot enough that it makes it easier to move the solder. So I'm just dabbing this on here. The more the better. You can't overuse flux. So okay, we're going to go over with our chisel tip, and we're just going to allow it to gather up. Get in here. Also, I have my soldering iron set to the hottest temperature. It's a matter of preference, but if you're going to set it to the hottest temperature and you're working on the chip, be careful because you can burn the chip. If you know what you're doing and you know how to move quickly, then the heat's not an issue. So we're just going to gather up this extra solder. Now, this isn't like an Xbox. There's a lot of little components on this board that we can ruin, so we want to be very careful. So what I'm going to actually do is, in order to get that little blob of solder that's left over off, we're going to use a this is actually an Xbox opening tool, but I'm going to drag it up onto here, and that way we don't risk dropping it on the board and ruining the board. So alright guys, so we've moved that the most of the factory solder that was on here off, but we want to do a second run with this copper braid to remove the rest and clean up these pads. So I actually have my Achi system set to preheat right now to keep it warm, and we're just going to run over and remove the rest. So I usually do 2 or 3 passes with the braid. We want it as clean as possible. We want that solder, that factory solder that's of poor quality. We want as much of it as removed as possible. So also, if you notice, there's a lot of flux on that board. That's because we want good lubrication. We don't want the soldering iron or the wick to be rubbing against the board. Like I said earlier, the PS3 boards are really delicate, so we want to avoid that. Okay, for the second pass, I'm actually going to cut off a piece of the braid and put it on the board. This, you can do it whichever way you prefer, but this is just my way. If you've ever heard that southern term, there's more than one way to skin a cat. Well, there's more than one way to remove factory solder from a board. So however, that doesn't mean every way is the right way, but that would come down to a matter of opinion. So this braid's getting filled up, so I'm going to take another piece and fill that up. What I'm looking for here is, even though the pads look clean, I want to make sure I get a really solid connection. So I'm going to do this a couple of passes until I see that the copper braid is clean and we got as much solder taken off as we can. So again, I'm going to drop the little piece on here. I'm going to go over it. Now I'm not pushing hard. I'm just enough to where it can make contact. You don't want to push hard. You don't want to rub these pads off. You don't want to damage the board. So this time I'm being a little bit more careful to hit every single spot on this array, or this pad array you could call it, and yeah. So we're pretty much cleaned up here. You don't ever want to jerk this thing. When the braid is on the board, if it sticks to the board, you need to heat it up. It should come off easy. If you rip it, you're going to destroy the board. Also, I want to show you, there's 4 points around the corner of this chip for alignment. If I can see right here. On some models, it'll actually have a little resistor right there. If you accidentally knock off the little resistor in the 4 corners, don't worry about it. They serve no purpose other than a marker. Also on those boards, some say that leaving those on there will actually keep the chip from dropping into place towards the end of this process. So that's all cleaned up. I'm going to hit it with the rag and wipe it up, and you can see how clean it looks. So now that I've done it with that, I'm going to flip on my cooling switch to cool off the board so we're not shocking it, and I'm going to go over it again with some isopropyl alcohol. This is 91% alcohol is what I use. If you talk to a lot of technicians, they actually recommend 99%, but nothing lower than 91 is what I would say, because you don't want water on the board. The 50% and the 60%, 70%, whatever alcohol will actually oxidize the board, and that oxidation is the enemy when you want solder to stick. So there we go, and we can see those perfectly clean pads, none are damaged. and we're ready to start reballing the chip, and we'll cut back in a second and show you.
Okay, go.
Okay, so here's our chip freshly pulled off. Let's get a close-up of that. That's our factory solder that we want to remove, and we're going to do the exact same process. I'm going to start by flooding it with flux. Like I said, Kingbo flux is good. It's cheap. We just want to create a barrier and make it easy to work with. I wouldn't recommend using Kingbo for reattaches or for doing reflows, but it definitely it's good stuff for doing the removes, you know. There's a lot of products out there, and you know, if you really want to learn this stuff, you know, use different products. Try it out, see what works for you. You know, it's all minor stuff when it comes down to it. So I still wouldn't recommend the uber cheap stuff from China, but you know, Kingbo is on the cheaper end. So again, we're gonna wet the with some leaded solder, and we're just gonna go over it and remove the first bit of factory solder. So. Go back and forth. I'm actually not putting the soldering iron to the chip. I'm just letting that little puddle we made sit on the chip, and we're going to move it around. So you don't want to be feeling the tip of the soldering iron make contact. Also, like I said earlier, I have my soldering iron set very high. It's set to 480 degrees Celsius, almost 1,000 degrees Fahrenheit. So if you hold it in one spot for too long on the chip, you're definitely going to kill the chip. So we don't want that to happen. So it doesn't have to be perfect at this stage, but the more we get off now, the less wick we'll have to use. So that's a good thing. So. Move some of that factory solder out of the way. You can see how dull this factory solder is. That's the problem. You can watch my other video called Lead versus Lead Free, and it'll explain why this stuff is so crappy. There's a reason they use lead free or leaded solder for so long. There's a reason why it's called lead free solder. They'd just call it solder if they didn't use lead prior. So again, I like to use it on the end of my wick just for my own convenience. In my light.
Wow.
Readjust my jig here. If you feel the solder wick to start to snag and it's not gliding perfectly, stop, because you will rip something and you will destroy these chip. This chip is about 40-50 bucks a piece, so it can be a little costly if you move with haste. So we're just getting the big pieces right now. We're going to go over it a couple more times like we did the board. Again, we want a clean connection. Also, making sure we get every little bit of solder we can off of this chip is going to make putting the new solder balls back on a lot easier. So just like I did before, I'm going to take off a little piece of this and I'm going to run over it. Might actually add some extra flux just to flood it even more. Be careful when you're adding flux. If you have this chip hot from the soldering iron and then you add new flux to it too soon, you're going to temperature shock the chip. The chip can't take drastic. If you go to rip and you think you might have killed it in the process, that my problem is not letting the chip cool all the way before it, or you add more flux, and also holding the wand on too long in one spot. We want to keep it moving as much as we can. So that piece of wick's filled up. I'll grab another piece of wick. This time the wick should be relatively clean, and that's how we know all the little points are, all the little pads are clean and free from. Oop, burned myself a little bit. Happens quite frequently. Don't expect to have feeling in your fingers after doing reworking. Getting burns is a job hazard for sure. Okay, this chip is clean. Now, like I said before, we don't want to cool this off too fast, so we're gonna let it sit for a second. I'm gonna wipe all the flux off with a clean rag, and then I'm gonna show you my secrets to reballing. So I'm almost out of isopropyl, but that's okay. So we're gonna clean this chip. We're gonna clean off the rest of that crappy King Glow stuff, so it's nice and smooth and clean. Again, if you guys want to learn this, there's no school for it. Practice makes perfect. Invest some money, invest some time, and don't take my word for it. Trial and error is the best way to learn, in my opinion. Okay, this is one of my secrets, guys. This is Quick Chip, or Chip Quick. Sorry. This is a paste flux. Now here's one of the big deals. If you put too much of this on, when it heats up, it's going to float, and all those little solder balls are going to move, and that's one of the biggest problems you'll have. So what I do is I put a dab in the middle. Okay, it's my big secret, guys. Take my finger and I rub it on. Okay, oh, came up out of my jig. So I rub it on a good coating, and then I'm going to take a dry finger, no pun intended, and I'm going to wipe it off like this. And then I'm going to take another dry finger and I'm going to wipe it off. And we just have a very thin layer, just enough to stick the balls in place. That's all we need. Any more than that, it's going to float around on you. You're going to have a bad time. Alright, so we got our stencil all aligned and set up, and drop this into place. You want to check it and make sure it's aligned perfectly. If it's not aligned perfectly, even just the tiniest bit off, everything's going to move around on you when you try and heat up the balls, and you're going to have a bad time. So we're just going to put on as many balls as we need. Don't have to overdo it. Now from the factory, these come with 0.6 millimeter balls. These are 0.5 millimeter balls. They're a tiny bit smaller, and it makes it a lot easier to work with. So we're going to move the jig around like that until it fills in all the holes. Go back and forth. And dump off the excess back into our bin. Now we want to check and make sure every single ball is perfectly in place, which I see one that's not. You're not going to be able to see it on the camera, but so we're going to tip it, and I'm going to nudge it. I'm going to try and take, looks like I pulled off a couple. So this is what makes reballing difficult. You have to be precise. You're just one ball out of place, and that's the same reason we had yellow light in the first place. So you got to be perfect here. So there we go. That one little ball was fried up, and now we're going to try and take the stencil off. And when we're pulling the stencil up, we want to make sure that it doesn't, none of the balls stick to it, because that's going to cause a bad time as well. So carefully lift that up. It looks like one ball stuck to it, so we're going to put it back on. If we remove it around, and we're just going to push down on that ball, and that way it comes. And now we got them all off perfect. Now what we want to do is do a check to make sure they're perfectly aligned, which they are all for the most part perfectly aligned. So now we're going to take our hot air one. So I always put the cap back on these. If you don't put the cap back on these and you knock it over, it's going to make for not a cool day, because you're going to have tiny pieces of lead all over your shop. And lead can be poisonous, even though it's a really small amount. Probably not a good idea. I'm going to set my air machine to 480 degrees. That's the highest it goes. Also, if you have one of these air machines, that comes with a lot of interchangeable tips, okay? I have found, for whatever reason, this is the best tip to use.
Where is it?
So I would use this size tip. I don't know what the size is off the top of my head, but if you look at it in proportion, you can tell. So yeah, we're gonna let this heat up all the way. Now, if we make a mistake doing this, we have to start all over again. So hopefully I don't. It does happen sometimes where they'll merge and the balls will move, or they'll bond to each other, and then you start from square one again. So we're going to try not to let that happen. I'm going to set my airflow to 2, which is very low, and we don't want to blow the balls around. We'll turn it up later on. So my airflow set to 2 and the heat on the highest it can possibly go, and we're going to start from a couple inches away from the chip. We just want to gently start heating up the chip. And we don't want the airflow to disturb the ball, so we're just going to go in a circular motion and just let it get warm. Now, how you tell when it's starting to heat up? You can smell it. This stuff has a distinct smell to it, so you'll know as soon as it's starting to heat up and it's safer to put the wand close. Okay, now I like to start at an angle and move back and forth. Again, I set my equipment to the highest setting, which might not be the best idea if you're a beginner. Everybody has their own way of doing things, but me, I like to keep it up high and just be careful of how long I'm holding it in one spot. You'll actually see these solder balls start to change color. They'll look kind of dull. That means they're starting to heat up and starting to bond. We don't need to get them all perfectly aligned or set in place, because there's a second step to this process that'll do that for us. So it's starting to heat up, so we're going to go around the chip. On PlayStation chips, I like to start on the outside first and work my way in. Usually by the time I get the outside attached, the inside's hot enough that we can do it with ease. So you probably can't see this on camera, but they're liquefying. They look really shiny, and they are jumping onto those pads, which is exactly what we want to see. So the one thing that's cool about PlayStation chips is they can take a little bit more abuse. So Xbox chips are really fragile. They're really cheap, and they're really easy to fry if you're not careful. This is actually an RSX chip, and it's actually developed by NVIDIA, which is why you don't see the yellow light as often as you see the red ring, or at least 6 months after buying it. This PlayStation was purchased in 2007, so it took it 5 years of abuse to go into the yellow light. So okay, so now what I'm going to do is I'm going to grab my magnifying glass, and you'll actually be able to, once you get a feel for it, you'll be able to see which ones are attached. And we're also going to make sure everything's aligned, and then we'll come back and show you the rest. Make sure to let this chip cool before you start the second part of the process. If you flood it with flux right now, you will shock the chip, you will kill the chip. So okay guys, so we got our Kingo flux again. We did a basic attach. We didn't have to get them aligned. This time we do. So I took it out of the jig and I'm putting it on my wood table. The reason I do this is because the aluminum jig will actually conduct the heat down away from the chip, and we're trying to heat the chip up. Therefore it's going to take longer. We're going to put more thermal stress on the chip, etc. So I'm going to take my Kingo flux here, take a good helping of it, and I'm going to flood this chip with it. I'm going to completely overdo it, and we're going to remove the excess when we're done here. So make sure everything's covered. Okay, so this time I still have my air one set to 480 degrees Celsius. But I'm going to turn the airflow up. Now that the balls are stuck in place, we don't have to worry about blowing them around. So I'm going to set it to about 3.5, and we're going to do the same process. We're going to start from a distance, and we're going to go down in. and you'll see that flux starting to melt and smoke. The smoking's a good indication that we're getting towards the temperature we need to hit. Now as this chip heats up, you're actually going to see the balls start to jump into place, and they'll be perfectly aligned for when we reattach it. Also, by flooding it with flux, we're making sure that we're getting a really good connection. So we're going to go back and forth. I wouldn't recommend going back and forth when you're doing the initial attach, because you're going to knock all the balls around, but now that they're attached, we can be a lot more liberal with it. So now it's starting to smoke. We're getting it to where we want it to go, and I'm going to start from the corner like I did before. Now again, you can't see it in the video, but these will turn a very shiny color, and you'll see them snap and jump into place. Okay guys, so now that we've heated up all the solder balls and made sure they're all melted and have fallen into place, we need to clean off the old flux. So that's very simple. We're just going to go over it with a toothbrush, regular toothbrush, and 91% alcohol. And we're going to scrub this clean to make sure we get all of that old flux off so it doesn't mess up when we're trying to do our reattach. So you want to get it completely clean to where all the flux is removed, and we'll come back and show you the reattach. Okay, so now we've reballed this chip and it's ready to go, and we're just going to align it back on the board, heat it up, attach it, put everything back together, and we'll come back for testing. Okay, so we're finishing some of the final stages of reattaching the chip, and you can actually watch when you do this yourself. You can watch the balls melt and the chip will align itself to the grid through the surface tension of the solder will actually pull it into place, and also you'll see it drop down onto the board, and so we know it's connected. Obviously it's a much lower temperature because we're using leaded solder to put this back on, and this will make a PlayStation last a lot longer. A reflow is just heating up the solder and filling in those microscopic cracks that cause the yellow light. This is a step beyond that, and this is replacing the solder that caused those cracks in the first place. So yeah, so I just thought I'd give you a view. It's heating up to the final stages, and if you get a shot of my profile, I actually have my bottom heater set to 265. Now we're worried about the heat on the top of the board. Even though the bottom of the board may be at 240, we want the top to be at 225, so it takes higher temperatures, especially with the thickness of the board. A PlayStation board is a lot thicker than a Xbox board, so it takes more heat to actually penetrate through. And our profile is going up to about 170. Also, my temperature sensor, I used to use the ones from China, which are like $3 a piece. This is actually an Omega temperature sensor, so its reaction time is a lot better, and it also lasts a lot longer. And it has a very small sensor, so you can get it much closer up underneath the chip. So anyways, I just thought I'd show you guys a little bit more of the process. She's steaming up now, so we know we're getting close to the melting point. So okay, so here she is, all put back together, ready to go. We got green lights, system is on, and it shouldn't have yellow light again for a really long time. Make sure if you're looking for a guy to do a repair, find the right guy. If you're in my area, call the only guy, the Computer Guy of Fresno. You can check me out on Facebook at the Computer Guy of Fresno, Facebook/ and also the ComputerGuyFresno.com. Thanks for watching, everybody. If you have any questions, feel free to ask. I do have my comments set to approval because I have been dealing with some harassment from a group, but I will approve the comments that are constructive, and I will give answers. So thanks a lot. Bye.